Hi everyone and welcome back to the Repair and Installation TV channel. The construction and installation of underground oil and gas pipelines is a meticulous process. It begins with careful planning and surveying to determine the optimal route, considering factors like environmental impact and regulatory requirements. The land is then cleared and graded, followed by trench excavation. Pipeline segments made of steel or high-density polyethylene are welded together and quality tested. The pipeline is lowered into the trench, aligned, and leveled. Backfilling is done, and measures like cathodic protection are implemented to prevent corrosion. The site is restored, and rigorous testing and inspections are conducted to ensure compliance and integrity. This process ensures the safe and reliable transportation of oil and gas, supporting energy infrastructure and the global economy. Oil and gas pipelines are constructed with a strong focus on minimizing environmental impact and preserving the integrity of the surrounding ecosystem. Great care is taken to ensure that the construction process has the least adverse effect on the environment. Measures are implemented to mitigate potential risks and protect sensitive areas. Environmental assessments and surveys are conducted to identify potential impacts and develop appropriate mitigation strategies. Techniques such as directional drilling and trenchless technology are employed to minimize surface disruption and avoid disturbing natural habitats. Additionally, rigorous monitoring and compliance with environmental regulations are integral parts of the pipeline construction process. By prioritizing environmental protection and sustainability, the construction of oil and gas pipelines aims to maintain the balance between energy needs and ecological preservation. The process of repairing a pipeline is a complex and meticulous endeavor that involves several detailed steps to ensure the safe and effective restoration of its functionality, the identification and assessment of the issue or damage in the pipeline. This can be done through routine inspections, remote monitoring systems, or reports of leaks or anomalies. Once the affected section of the pipeline is identified, isolation and depressurization are necessary for safety during repairs. Valves are closed, and the pipeline is cleared of any remaining product or pressure, which can involve trenching or creating access points. Strict adherence to safety protocols and procedures is paramount to prevent accidents and protect other underground utilities. After the damaged section is accessible, a detailed assessment of the damage is carried out. Visual inspections, non-destructive testing, and integrity analysis are performed to gather information about the nature and extent of the damage. This assessment informs the decision-making process for the appropriate repair method. The repair or replacement phase is then determined based on the assessment. For smaller cracks or leaks, repair techniques such as welding, clamping, or composite wraps may be employed. In cases of severe damage, a section of the pipeline may need to be replaced entirely, requiring cutting and removal of the damaged portion. If welding is necessary for the repair, certified welders perform the required procedures to ensure the strength and integrity of the pipeline. After the repair or replacement is completed, a comprehensive inspection and testing process takes place. Non-destructive testing methods such as X-ray, ultrasonic, or magnetic particle testing are utilized to verify the quality of the repair and ensure there are no defects or vulnerabilities. Once the repaired section passes inspection, the trench is backfilled using suitable materials. Proper compaction is ensured to restore the stability of the ground. The repaired section of the pipeline undergoes recommissioning. Systematic checks and monitoring are performed to ensure proper functioning and to detect any potential issues. The process of transforming individual 12-meter lengths of pipe into pipe stocks and installing them as subsea pipelines offshore involves meticulous steps and adherence to industry standards. The fabrication facility specializes in fabricating various pipeline configurations, including single pipelines, pipe-in-pipe pipelines, electric trace heated. The fabrication and assembly process begins with numbering and inspecting each 12-meter length of pipe. These sections are then processed at the alignment welding station, where the ends undergo preheating for optimal welding conditions. Utilizing both mechanized and manual techniques, the welding line and cycle commence, systematically joining the sections into pipe stocks that can span nearly 1 kilometer in length. The welding procedures adhere to the highest technical standards, ensuring the integrity and strength of the pipelines. After the welding stage, the pipes undergo thorough visual inspection to identify any surface irregularities or defects. Subsequently, they are subjected to non-destructive examination techniques such as radiography, ultrasonic examination, and magnetic particle testing to verify the quality and integrity of the welds. The weld areas are then coated in the field joint coating area using specialized systems such as polypropylene tape wrap or injection molded polyurethane or polypropylene coatings, providing enhanced protection against corrosion and mechanical damage. Once completed, the pipe stocks are carefully stored and prepared for pipe-in-pipe applications. Hydraulically operated push frames are utilized to insert the inner flow line pipe stocks into the outer carrier pipe stocks. Each push inserts 4 meters of pipe, and multiple pushes are performed until the desired length of the pipe in pipe stock is achieved. At the tie-in station, the individual pipe stocks are connected. The ends of the inner flow line pipe stocks are welded together, followed by non-destructive examination techniques to ensure the quality of the weld. Insulation and fire retardant blankets are applied to the weld area for thermal insulation and safety. The carrier pipe stock is then pulled over the welded section of the inner flow line, completing the connection. This meticulous fabrication and assembly process continues as additional pipe stocks are connected and spooled onto the vessel's reel until the desired length of the pipeline is achieved. Welding and joining play a crucial role in the fabrication and assembly of pipelines, ensuring their structural integrity and functionality. The welding and joining processes involve meticulous techniques and adherence to industry standards to achieve high-quality results. Certified welders with expertise in pipeline welding are responsible for performing the welding procedures. They follow stringent guidelines and utilize advanced welding equipment to ensure strong and reliable connections. The pipeline sections to be joined are carefully inspected, cleaned, and prepped to remove any contaminants or surface imperfections. This is crucial to ensure optimal weld quality and prevent defects. Common welding techniques used in pipeline fabrication include shielded metal arc welding, gas metal arc welding, and flux cord arc welding. Each method has its advantages and is chosen based on factors such as pipe material, thickness, and project specifications. During the welding process, welders meticulously control parameters such as heat input, travel speed, and electrode selection to achieve proper fusion and penetration. This is vital to create sound welds with sufficient strength and integrity. To ensure the quality of the welds, non-destructive testing techniques are employed. These methods, such as radiography, ultrasonic testing, and magnetic particle inspection, enable the detection of any defects or discontinuities that may compromise the weld integrity. Non-destructive testing techniques helps to verify the soundness of the welds and ensure compliance with industry standards. In addition to welding, joining techniques such as flange connections, mechanical connectors, and coupling systems are utilized in pipeline fabrication. These joining methods provide efficient and reliable connections between pipeline sections, allowing for easy assembly, disassembly, and maintenance. Strict adherence to safety protocols is maintained to protect the welders, ensure workplace safety, and prevent any environmental hazards. Welding activities are carried out in compliance with occupational health and safety regulations and industry best practices. Before putting the welds into use, it is crucial to perform a comprehensive inspection to ensure their quality and integrity. This process involves meticulous checks and testing to detect any potential defects or flaws that may compromise the performance and safety of the welds. Non-destructive testing techniques, such as radiography, ultrasonic testing, magnetic particle inspection, and dye penetrant testing, are commonly employed to examine the welds for any hidden or surface defects. These tests enable the identification of issues such as cracks, porosity, lack of fusion, or incomplete penetration. Additionally, visual inspections are conducted to assess the weld appearance and evaluate its conformity to the specified standards and requirements. By thoroughly checking the welds before their utilization, any necessary repairs or adjustments can be made to ensure that the pipelines operate reliably and meet the stringent industry standards, mitigating the risk of failures or accidents during their service life. A spool base is a specialized facility dedicated to the fabrication of pipelines, specifically the assembly of pipe spools. The spool base plays a critical role in the construction of subsea pipelines for the oil and gas industry. At the spool base, individual pipe sections are transformed into pipe spools through a meticulous fabrication process. This involves the cutting, welding, and assembly of various lengths of pipe to create continuous sections known as spools. These spools are then transported offshore and installed as part of the subsea pipeline infrastructure. The spool base is equipped with advanced welding and joining techniques to ensure the strength and integrity of the spools. Certified welders perform the necessary welding procedures, following industry standards and regulations. Quality control measures, such as non-destructive testing, are implemented to verify the quality of the welds and ensure they meet the required specifications. In addition to welding, other critical activities take place at the spool base. These include surface preparation, coating application, and inspection of the spools. Surface preparation involves cleaning and treating the pipe surfaces to ensure proper adhesion of protective coatings. Coatings, such as corrosion-resistant coatings or insulation materials, are applied to enhance the durability and performance of the pipelines. Thorough inspection procedures, including visual inspections and non-destructive testing, are carried out to detect any defects or inconsistencies that may compromise the quality of the spools. The spool base also serves as a storage and logistics hub for the fabricated pipe spools. The completed spools are carefully stored and organized, ready for transportation to the installation site. Effective logistical planning ensures timely delivery and coordination with offshore operations. At the spool base, various essential activities complement the welding process, ensuring the fabrication of high-quality pipe spools. Surface preparation is a crucial step that involves meticulous cleaning and treatment of the pipe surfaces. This preparation is necessary to remove any contaminants, rust, or scale that could compromise the adhesion of protective coatings. Once the surfaces are properly prepared, coatings are applied to the pipe spools. These coatings serve multiple purposes, such as protecting against corrosion, improving insulation properties, and enhancing the overall durability and performance of the pipelines. Corrosion-resistant coatings, such as epoxy or polyethylene coatings, are commonly used to safeguard the spools against the corrosive effects of the environment or transported fluids. Insulation materials, such as polyurethane foam, may also be applied to minimize heat loss or maintain temperature stability within the pipelines. To ensure the integrity of the fabricated spools, thorough inspection procedures are implemented. Visual inspections are conducted to detect any visible defects, such as surface irregularities, weld discontinuities, or coating imperfections. Non-destructive testing techniques, including ultrasonic testing, magnetic particle inspection, or radiographic examination, are employed to identify internal or hidden flaws that may compromise the structural integrity of the spools. These inspection methods enable the detection of defects or inconsistencies, allowing for timely corrective actions and ensuring that only high-quality spools are utilized in the pipeline construction. Quality control and assurance play a vital role throughout the surface preparation, coating application, and inspection processes at the spool base. Strict adherence to industry standards, specifications, and regulatory requirements is maintained to guarantee the reliability, safety, and longevity of the fabricated pipe spools. By incorporating these critical activities, the spool base ensures that the pipelines meet the stringent quality standards of the oil and gas industry, providing efficient and reliable transportation of fluids in subsea environments. Components in place during the soldering process. These molds are made of heat-resistant silicone materials that can withstand the high temperatures involved in soldering without deforming or releasing harmful substances. The use of silicone molds offers several advantages in soldering joints. Firstly, the molds help to ensure accurate positioning and alignment of the components, resulting in precise and reliable solder joints. The molds act as a barrier, preventing solder from spreading or flowing onto unintended areas, which can cause short circuits or other connectivity issues. Additionally, silicone molds provide stability to the joint during soldering, reducing the risk of movement or misalignment that can lead to weak or faulty connections. The molds hold the components firmly in place, allowing the solder to bond securely and evenly distribute heat for optimal soldering results. Silicone molds are available in various shapes and sizes to accommodate different joint configurations and component arrangements. They can be customized or designed specifically for particular soldering tasks, ensuring a tailored fit and optimal performance. After soldering is complete, the silicone molds can be easily removed without damaging the solder joint. The flexibility and non-stick properties of silicone make it easy to release the soldered components from the molds without any residue or interference.